Welcome to the Tube Barn. If you haven't been here before, this is a channel giving basic information about the construction of a tube guitar amp. This isn't a technical manual, and if you haven't seen these videos before, please check out my channel and see the other videos. This is video number 4. We will be talking about capacitors. Since the previous video, we talked about power rectifiers, converting AC into DC, and now we're going to discuss the capacitors, specifically the smoothing capacitors. Now, this is one type. They're a can. I do like using these types. They also come in various other types. And depending on how you're going to set up your amp, that will decide what type and shape you will be using. Now, these used to be called, or they still commonly called, filter caps, but that name's kind of dumb, and so people change it to smoothing because it's a little bit more accurate. Now, if we go back to the ripple from the last video, just right here, this is what happens after you rectify your DC. You're changing your AC to your DC, but you're left with ripple. And that's because the AC, or I should say the AC sine wave, can only hit so many points at a time. There is a time between each phase, the right or the left or the up and the down, depending how you want to talk about it. So what happens is you're left with this little tiny ripple here, and you need the capacitors to fill those gaps. Now you can imagine that with a 50 to 60 times a second cycle, depending on if you're in the US or another country, here in the US it's 60 times a second, you're getting those tiny gaps. So every time your voltage drops, it discharges and fills that gap. And fills those gaps. Imagine how many times it's doing that a second. It fills those gaps until you get a clean line DC. Now capacitors are rated in farads, or in this case, it's microfarads. Now this is a 50. This type is also a double. It's a can cap. It's got a negative and 2 positives. So these could be used separately in conjunction. You could do some crazy wiring for some other configurations I'll talk about in a minute. But so this one can be used in 2. Or in the case that I tend to do, because it's only 50, that I will wire them together and use them as one, turning it into a 100 microfarad, or what's referred to down here is UF. You're going to see that UF, NF, and PF, which is, I guess U stands for microfarads for some reason. That's just the way life is. You got your N for nanofarads and your P for picofarads. So sometimes you'll need to know the conversion if you're reading it to know exactly what it is. So like 47 nanofarads is 0.047 microfarads, and so forth. It gets stranger and bigger numbers with the picofarads. Now, let's talk about the power supply circuit. Now, when you got your power supply, this is what it's going to look like, more or less, in your amp. You could have additional, depending on the size of your amp, how many preamp channels, how many stages. But this is pretty standard here. Now, let's learn some symbols. That's a symbol for a diode. That's what you use to rectify. We talked about that in the previous video. This is the sign for capacitor. Now, I forgot, a lot of times when you're in there, you'll see its orientation. This one's just lower because I was drawing bad. Positive. This is your negative. This is ground. These are your resistors. So when you're building your power supply in your, remember we're talking about a tube guitar amp. This could go into similar to basic straight amps and whatnot, but we're talking about a standard guitar amp here. So the first one you refer to as your B plus supply. That's pretty standard when they're talking about your initial power. It could be a single I will call it a stage for lack of a better word right now. A single stage power supply, which is your primary power. So when you see B+, it's usually your main power. In this case, this is the power to the plates of your power tube. Now the next one is Z, which we refer to as Z, is the screen on your power tubes. The Y will go to your phase inverter, which is a completely different tube from your power tubes, but it's the stage just before your power tubes. And then you have your X, which goes into your preamp tubes. Those go to the plates of the preamp tubes. All these are going to, well, not that one. The B+, your Y, and your X are going to the plate voltage. This one goes to the screen. We'll talk about that later. Now, so how does this work? Well, let's get back to our rating. You got your 50. That's pretty standard. It's a lot of people use lower, 20, 22, depending on amps. You'll see older amps with less. Personally, I like to use 100. We're talking about capacitance. The higher the capacitance, the more oomph your capacitor has when discharging voltage into your circuit, into your power supply. Now with me, I like my B+ on 100. The amp that I'm going to build, I have 120. There's a reason for that I'll get to in a second. Now, sorry, upside down. Now, this is rated for 500 volts. Now, you need to make sure that you have a significant amount of headroom. We should all know what headroom is since we're all dealing with guitar amps. You know, your speaker needs to be able to handle a hell of a lot more power than your amp can throw at it, or you're going to blow the freaking speaker up. Your cone's going to die. You know, especially if you're using horns and tweeters and crap. Those things will just die. I've killed many an amp miking up drums. That is just a death sentence. In this example, say you have 400 after rectification, 400 volts at your B+. This 500 is fine. Probably even 425. You may be able to get away with it at 450, but you probably want to do it higher. Now, I got this one here. This is rated at 600 volts. It's 120 UF. So it's a single. It's a snap-in. Now, the reason why it's a snap-in, because when you're building your amp, you're going to find that getting parts is kind of a pain in the ass when you get to a certain amount of voltage. Several years ago, when I first started this in about 2011, you could buy the stuff all day long, high voltage stuff. It's just not around anymore. This one I got from a electronics supply at Newark.com. They sell all major, it's a major supplier. Now the stores like the Tube Depot, Mojo Tone, Amp Parts Direct, there's many out there. They generally don't sell these anymore. Now they do have the Sprague Atom that you can still find. It's a 600, I think it's still 600 volts, but you're only getting about a 20, I can't remember, 20, 22 UF on those. So if you're going to use them, you're going to have to stack them in parallel. And just so you know, when you stack, I mean in parallel, this would be parallel. Well, take out the resistors, but they're running side by side. So let me just make sure I have that. Lost my pen, there it is. So basically you have parallel. These are connected. And it's a crappy drawing, but you get the thing. They're running in parallel, meaning they're both working in unison. Now, resistors and capacitors are different. If you run your capacitors in parallel, it increases the capacitance. Now, if you run your resistors in parallel, it does the exact opposite. It decreases. Now, if you have perfect numbers, it'll divide, it'll add, multiply, what do you want to call it? Say if you have 100 and 100, that'll turn it into 50. If you have 50 and 50, that turns that into 100. Now, when you're running, we'll just call this ground, doesn't matter, doesn't need to point down. And, well, whatever, this is just your point. So, when you run your capacitors in series, which is one after the other, daisy chaining it, it divides it. So if you have 100 and 100, you're going to end up with 50. But the difference is if this capacitor is only rated for, say, 200 volts, you're going to now get, instead of two 100 UF capacitors rated at 200 volts, you're going to get one big capacitor at 50 UF at 400 volts. Now you'll see this in some of the older designs, and actually some people have seen these higher rated things, these higher rated capacitors, and opened them up and found out that that's what they did inside them. So you never know what you're going to get. Always buyer beware. If you can avoid doing any weird crap with your amp, do it. Because even though this is common, I should say it has been common known to use. They add some resistors in here as well in parallel with this thing. If you have a failure, it's going to be bad, because you're going from being able to have the proper voltage in this to not having the proper voltage in it, and it's just going to just going to send some shit. You're probably going to melt the freaking other one, and God knows what the hell it's going to do in your circuit. So I don't like doing this. So I see if I can find one as with the highest voltage I can to use. Now, in my amp, I can get away with this, even though it's a B+, we'll call it B+ voltage of 474 volts. So that's 26 off. I mean, it's not recommended to do that. You really shouldn't do that. But the fact is, I can do it for a couple reasons. And one of those reasons is the amp I'm going to build is probably hardly ever going to be used. It's going to sit on the shelf as a look what I did, because this is a hobby of mine. 2, now, these capacitors, unless you're buying garbage, like, don't buy garbage. Just fucking don't buy garbage. You get what you pay for. Seriously. You buy garbage, you're going to get garbage. It's just shit. Don't go on a freaking Wish or Alibaba or anything like bullshit. So, what was I saying? I got on a tangent again. So anyways, capacitors are rated at a certain rate. There's always headroom in them. And so we're talking about spikes. We're talking about a 26 volt spike, which would be approximately, give or take, a 10 volt spike on your power supply. Now, unless you live in the middle of Costa Rica out there in the OSA, where you get those crazy gnarly spikes out there, you'll probably be fine. With that said, if you're in an area that has horrible power, it just fluctuates, you can get a lot of items, regulators, what's it called, a firma, I can't remember what's that, what that rack space thing, it's a power conditioner. They also make little plug-ins that look like those little 3-prong to 2-prong things. They're like that, except what it does is it acts as a regulator. Anything over a certain voltage will be shoved to ground. Now the problem with that is you got to know what you're buying, because with the increased voltage and supplies, it could eventually be working all the time. I've seen those things turn brown because they're always doing it, which means you're wasting power, and that thing could fail. Also, if where you're at isn't grounded for shit, then you're not doing anything. And you need to know where you are, and if you're running around, well, if you're running around and touring, make the thing right. Seriously, if this is going to be your really cool amp, the amp that you're really using, find the money, get the right stuff, or two, use a power supply that's a little less. Means your power transformer needs to be at a little lower rated. Mine are strong, just the way I had them built. So don't get a power supply, or I should say don't get your transformer that's going to be too high. Also, when dealing with capacitance, too much capacitance is a bad thing. I believe some around 220 microfarads on your B+. You don't want to go higher than that. Your system can't deal with that. Your tubes may not like it either. But if you're using a rectifier tube instead of a solid state rectifier, meaning diodes, you're using an actual rectifier tube, you need to look at those tubes and see what they're rated. Because if your capacitance is too high, you're going to get arcing inside of your tube at startup, and that's not a good thing. Now, it may work when the tube is new, but eventually when it gets a little older, more worn, that's when you're going to really start seeing it. So figure that out and see what's going on with that. I haven't dealt too much with the rectifier tubes. I don't use them. I'm going to build one eventually, but we'll see. Some may look at this and say, hey, this should be a choke and not a resistor. And I'm telling you, no, it doesn't. It does not have to be that. I build many amps and I use resistors in this position and no choke, and it's fine. I used a choke once. I found no difference. With the low capacitance of rectifier tubes, maybe you want to look into having a choke because it may help out. Now, I've seen circuits with a choke and a resistor in series in between these two positions, and that works too. A choke basically looks like a transformer. It's very similar. It's very small. It has the windings and it helps with the ripple. Now, one thing about a choke is it has very, very low impedance, which means low resistance. So when the difference of voltage between your B plus and your Z is going to be pretty insignificant. Now, if you're using certain tubes, say like in an EL34, like I'm going to use in the amp I'm going to build, you definitely have a lower voltage on your screen than what you could have on your plate. Now, I deal with a lot of 606 amps, and you can have those pretty high, but the fact is I'm using that 474 plate voltage, and the EL34s don't really care for that high screen voltage. I'm just going to use a 10K resistor, and like I said, I usually use resistors instead of chokes. Now, they say if you don't use a choke, use a high value resistor, and the 10K should just works fine, even though I've used lower than that and never seen any issues. It's all about your build and how clean it is and your transformers and things like that. Now let's talk about orientation of your capacitor, especially when it comes to your bias circuit and negative voltage. Now, well, remember, we have your plus like this. You got your plus to ground. Now, let's move this down. And your basic bias rectifier. Now you can see you have your negative to your supply and your outlet, and you have your positive to ground. It works the same way. It just is now working on negative voltage. There's a little bit more to the circuit than what I've drawn. Of course, you're going to have your various resistors, a trim pot, and another capacitor after that. It all depends on what your supply voltage is and what you want to get out of it. So we'll get into more of that later when I'm building that part of the circuit. Bro, it's cold. I know it's cold. I gotta finish the video. I know, bro, but there's snow on the roof. What the hell? I said I'll finish this when I'll finish it. Do what you gotta do. Okay, bro, I'll do what I gotta do. You gotta do what you gotta do, bro. Swear to fucking God. So anyways, let's get back what we were talking about. Let's discuss the capacitors that you're going to commonly come across when building these amps. This one here is what is referred to as an orange drop. It may not actually be an orange drop since it's a proprietary name and the company's been sold and copied over and over, so technically it may not be an actual orange drop, but it's a polypropylene capacitor, commonly seen in more actual stereo amps and more clean amps, there's an argument if it's actually cleaner or not, but let's not get into that. If you do want a clean tone and going for that Fender build, I would say maybe use that. But before we get into the other types, let's just discuss capacitors. Now, what do? They block DC. They allow the AC current to go through, which is your signal. Because if you look at the circuit, your signal coming into your grid, you have your cathode down here, and you have your plate. There's a resistor up here. We'll talk about that later. Now the signal comes in, it shoots up here, once amplified by the tube, and comes out with a mix of the increased AC signal and the high voltage DC, which could be from 1 to 300 volts depending on your circuit. This blocks the DC and allows the AC signal to move through it. Now, one thing to realize is depending on the rating, similar to your cathode capacitor, the higher the rating, the more low end it allows through. It's different, but you get my point. So if you have a low rating, meaning a 1 pico, it would be almost nothing, just super high frequency, or you get your 1 UF, which you will see in more mixers and vocal preamps and high fidelity amps. But anyways, this is, what is this, a 22, I believe. I put my glasses on. Yes, this is a 0.022 UF. This is very commonly seen in guitar amps. Now remember, guitars can only do so many frequencies, high and low. So this is a good capacitor value for a guitar amp. You start getting into bass amplifiers and you start getting into the 0.047s because that lets a little lower frequency come through. Now you see here, a lot of times you have a resistor past this. It's either going to be a grid stop resistor, or like this one, it's an attenuating circuit, meaning that this is a voltage divider. Depending on its values, it's going to cut it in half, quarter, or more before it goes on to the next stage. Now, these resistors kill your signal frequencies. The higher the value, the lower it kills. So if you only have a very small value, it's only killing the very top high frequencies. The lower you go, it's going to be killing it even more. And trust me, you can definitely hear it. So what you do is you get your little silver mica resistor, which is what they're using now. You might be able to get some ceramics that work there, but generally the silver micas work very good. What happens is it jumps that signal that's being cut out past the resistor to continue on. So you get that lower voltage, but you're getting that signal back. And you can see a 470 pico and a 470K tends to be even. I guess that's the way that works. So a couple, or I should say another way you use these, and the ceramics work very good for this, especially in power supplies where you want to get high frequency noise gone, is you take your signal with your capacitor and you send it to ground. That way that portion of the signal is gone. It takes it away. If you have some really fuzzy, weird noise at the top end of your signal, you could probably use a capacitor to bring it to ground if it's significant enough, but like I was saying, whatever you lose, you lose. If you have a nice tone within that range, you're going to lose that as well. So unless you have a really serious issue, I'd avoid doing that. And if you do have that serious issue, you may want to look at what's causing it in the first place before trying to get rid of it. Now, let's talk about the other types. These are Mallory's. These are a metallized film, or I think it's vinyl, something like that. Something similar to Mylar. The Marshalls tended to use those, the old mustard caps. Now, before the keyboard warriors zip their pants down and start typing frantically, what I say in these things is general. No, is that exactly what Marshall used? No, it's not. Those things are gone. Good luck with that. I'm just saying, calm down. This is basically the type of things they use. Now, these are the Mojo Tone. They call them Dijon. I'm assuming that is their interpretation of a mustard cap. So, use these things. You do see things in Marshall. In the amp I'm going to build, I'm going to use these type for a couple of reasons. One, I'm going for that Marshall tone. And two, these are really tall and bulky, and when I'm building, I really want to show you what's going on, especially when you have multiple things moving around them. So it's just going to be a bit of cleanliness. Now, let me get to something I was poking at just a moment ago, and that is forums. Go to a forum at your own peril. Now, they're great to find information and read information if you can find it, but ask a question at your own peril. And the reason why is because forums are where loser bitches go to feel like a man. I mean, seriously, you've never seen, just like freaking Star Wars said, a more wretched hive of scum and villainy, but in this case, dipshit assholes. Now, are they all that way? Absolutely not. Are most of them that way? Oh, God, yeah. It doesn't matter if it's film, electronics, gaming, how to build a game, or freaking needlepoint. You're going to get all the same stupid assholes. Oh, why do you want to do that? Stupid bullshit. It's like, just answer the question. If you don't know, then shut the fuck up and go away. Now, to give you an example, way back when I had an issue where I was still learning, and my entire power supply was wigging out. And that's when I learned that you can't have a full wave bridge rectifier and ground the anode and ground a center tap of that secondaries in that transformer, which is what I learned after this. But as I'm asking people, literally no one could fucking answer the question. Not a single person in the entire fucking thread who gave me the bunch of shit, even though I'm giving exact verbiage like I just said. Here's it is and here's what I'm doing. Literally couldn't. And you have that one asshole, and he's in every freaking thread. I need to see a schematic. I'm like, it's a full wave rectifier bridge. I need to see a schematic. If you're in a forum trying to help people as if you know something and you don't know what the hell a full bridge rectifier circuit looks like, you need to get off and just shut the hell up. But anyways, I gave him the schematic, which I just took off the internet because it's pretty simple. It's standard. And he came back and said, no, I need the whole amp. And which was really stupid. And I said, well, there is no amp. The amp isn't actually wired together. The amp doesn't exist. It's a full wave rectifier bridge by itself. I explained the whole thing. I have the center tap and everything else grounded, and he comes, I still need to see this, see the schematic. And I'm like, why? This is like if you told somebody, hi, I'm having a problem with my car battery. And he said, I need to see the schematic of the car. The battery is 65 feet away from the car, is sitting on a shelf. It's having problems. I need to see the schematic. This is the full retard bullshit that you're going to deal with in forums. All of them. Now, there was one time when I was looking for a voltage for a bias supply. And I laid out my question as best I could. And the first response literally was just 2 digits, 46. So 46. Now, I got hung up with the fact that a whole bunch of people started commenting, and it got to the point where you got people screaming, oh, he's not a builder, he's none of this, blah, blah, blah. Fucking just asshole bullshit. Like I said, Maybe 1 out of 10 times will the answer ever be given. In this case, it was true, because once I figured out the shit by myself by just searching the internet, the answer was 46. It was really nice. The guy literally was like 46. So it is there. They do it. But like I said, fuck forums as far as asking questions. Seriously. Forums make the comment sections in these YouTube videos seem like a fucking paradise, and we all know they're a bunch of trash. But that's my rant for the day. I hope I've helped. Comment, subscribe, hell, put the bell, whatever you got to do so people actually see these videos. And remember, this is a series. I am going to build an amp, and well, if you think I'm a fucking retard, say that too, because at least I'm getting some shit. So there you go.